everybody, Codemaster X here. This is the C# Basics tutorials. We're going to be talking about logic now. The last video we talked about how to work with variables, how the variable types are important, and how to cast variables, that sort of thing. And now we're going to be talking about how to work with logic. Now, there's a couple of things that we need to do. Let's go ahead and remove that. And so we need to have a couple of things. And there's a game that you can create. So we're going to be creating our very first game here. There's a game that you can create that really kind of showcases how programming works and how logic works in programming. And it's basically the hot cold game where you guess a number between 1 and whatever. So we're going to be creating that game, and we'll talk about kind of how that works. So we need to create an integer, and then we basically need to tell it that it needs to be a random number between 1 and 10. So we're going to do that. We're going to say answer equals a random. Sorry, is it under math? It is random. So we need to create a random here. So random r equals new random, and then we'll do date time dot now milliseconds. So that's our seed. We want to make sure that our seed is different each time. Computers are pseudo random, which means that they're never truly random. If you understand where the starting point was, when a user did something, how many times a user did something, you can predict the random. And so that's why when we're talking about like people guessing people's passwords and stuff like that, even though they're encrypted, it's essentially them guessing what the original number was that they used for the random, and guessing the encryption method that they used, and then guessing a number of other parameters to be able to crack that and use it. The seed is essentially the starting number. We want to make sure that's different every time we start our application, so that when people play our guessing game, that the answer that it comes up with is different every time. So we're going to do r dot next, and so we want to have a number between 1 and 11. Now, the reason that we're going to be doing 11 is because the minimum number is inclusive, which means that it includes that number, and the upper number is exclusive, which means it excludes that number. So essentially what we're saying is we want a number between 1 and 10. We're not saying we want a number between 1 and 11, because 11 is the upper bounds. It is exclusive, which means that it is excluding that from our thing. There's mathematical reasons for why it does that. Some languages are both inclusive numbers on that. Some languages are inclusive, exclusive. So you need to look up in the documentation for the library that you're using, and ensure that you understand whether or not your stuff is inclusive or exclusive. Okay, so the next thing we need to do is we need to get our guess. So we're going to preset our guess to 0, and then we're going to be doing a while loop. And this is awesome because a while loop allows us to essentially run the program and run that loop until something happens. So until a condition is met, it will continually loop that. And so what we're creating is called a main loop. Now, Every single program running on a computer has a main loop, whether it's a video game, whether it's your operating system, whether it's your favorite art program. All of them have a main loop. So our main loop is going to look like this. While guess is not equal to answer. That is our main loop. And so you can see loop control value is never changed in loop. This is okay for now. Essentially, it's telling us right now we have an infinite loop, so it'll never stop. We're going to change that here in a second, but I just kind of wanted to show you that our while loop, right, that is our condition for stopping. Once guess is equal to answer, it will break out of this loop and do something else. So at the end, we're going to say console.writeLine, you win. Let's do that in all capitals so they know. Okay, so the next thing we're going to do is we're basically going to be getting our guess from the user input. So what we're going to do is we're going to say console.writeLine, guess a number between 1 and 10. And then we're going to be getting our user input, but we're going to do something a little bit differently, and I'll kind of explain how this is going to work. We're going to use our int.tryParse. Remember last time in our last tutorial, we used parse. So we're going to get our read line, and then we're going to set out our guess. Okay? So essentially what we're saying is we're going to try to parse our read line. If it's successful, then we're going to set that to our guess variable. And so we're going to say if try parse, because if we look at try parse, it actually outputs a Boolean on whether or not this was correct. So if it's true, then we're going to run our game. If it's false, then we want to tell our user your guess was not a number. Please ensure your number is valid and between 1 and 10. So the next thing we need to do is we need to say if our guess is less than 1, or is 2 pipes, that is shift / that's above your enter key. So it's shift the number or the key above your enter key on most keyboards. And then if it's greater than 11, now you'll see the new version of Microsoft Office, the new version of Microsoft Visual Studio has some AI in it that tries to guess what you're attempting to do next. And if it does that and you see it like grayed out, you can hit tab to accept it. So this is our code. If our guess is less than 1 or greater than 11, then we want to tell our user your guess was out of bounds. Please guess a number between 1 and 10. Okay, so now this is basically just error checking and ensuring that our user input is correct. So now we're 100% certain that they've inputted a number and that number is between 1 and 10. Actually, this needs to be 1 and 10. So make sure you make that change in your program. I'm going to go ahead and make this just a tiny bit bigger because I've noticed on stream it was a little hard to read. So I'm going to make that just a tiny bit bigger. All right, so the next thing we're going to do is the main body of our application. This is the actual game logic itself. So we're going to say if guess equals answer, then we are going to continue. And essentially what that means is, you know what, let's flip this around, because we can do a little bit less code this way. So we'll say if guess is less than answer, else if guess is greater than answer, and then we'll do the rest the other way. Okay, so if our guess is less than our answer, then we want to tell our user higher and lower. So if our guess is lower than the answer, we want to tell them higher. And if the guess is higher than answer, we want to tell them lower. So let's go ahead and run our game. And so the first thing I'm going to do is I'm going to say Mr. Code Master X. It says your guess was not a number. Please ensure your number is valid and between 1 and 10. So let's do 50. Your guess was out of bounds. Please guess a number between 1 and 10. Now you'll see that it actually says lower. This is a bug. We actually don't want that to happen. So if we're here, we actually want to continue. Essentially, what this keyword continue does is it tells our loop, ignore everything after this, and then go back to the top. So now if I do 50, it doesn't say lower anymore, right? It could potentially cause bugs. We want to make sure that we're not continuing our execution of that particular iteration of the loop, and we want to push forward. So guess a number between 1 and 10. We're going to go 4. It's higher, 6. Higher, 8. Higher, 9. We won, right? So let's go ahead and break this down line by line, and we'll talk about how this works. So we're creating a new instance of a variable R, which is our random. So we're creating a new random instance, right? An instance is basically like, let's say that you have 4 quarters, right? Each one of those quarters is an instance, right? They're all a quarter, but they are each individual quarters, right? That's how instances work in programming. You can create a new instance, which is essentially basically like stamping a new quarter, right? We are passing in the value of datetime.now, which is basically saying whatever the time is right now, time and date of right now, and we want to grab our milliseconds. Then we are getting our answer, what our answer is going to be, which is random between 1 and 11, which is why we're doing r.next. That is our range, 1 and 11. Remember, the top number is exclusive, which means that it's basically top number minus 1. So our answer is going to be between 1 and 10. Then we are initializing our guess variable. We need to make sure that that is initialized so that we can actually use it. And we are going to be using it in our while. And we're going to say while our guess is not equal to answer. That is our main loop. That means our program is going to continually loop around and around until guess is equal to answer. Console.writeLine writes that text to the screen. Then we're saying if try parse console.readline outguess. Essentially, we're saying console.readline, we want to take whatever that is, and we're going to try parsing that into a number. If that fails, we're going to tell them that their guess was not a number, and then we need to make sure it's valid and between 1 and 10. If it is a number, then it's going to set our guess equal to the number that was parsed, and we do that with the out keyword. You'll see that right here. So we are passing basically what the out keyword does is we're saying we are taking that and we're passing that out into this variable. Then we're seeing is our guess less than 1 or greater than 10, then we're going to be telling them, again, it's out of bounds. It needs to be 1 and 10. And then we're continuing, which essentially means ignore the rest of this iteration of the loop, right? And then go back to the top and try again. If we are within 1 and 10, then we're going to check to see if our guess is less than answer. If it is, then we're going to tell them it's higher. If it's greater than the answer, we need to tell them it's lower. And if it is equal to the answer, then it's going to ignore this else because, right, we've already checked that up here. And it's going to bounce back up here, and it's going to check, is guess equal to answer? Well, in this instance, yes, it is. Then we tell them they win, and the program exits. So this is how to work with logic. Logic is the bread and butter of coding. If you're good at logic, then you are good at coding, essentially, because everything in programming is logic. One thing I like to basically say is everything evaluates to a true or a false when it comes to logic, right? So if we look, guess not equals answer, right? So if guess is 1 and answer is 5, so does guess not equal answer? True. It's true. It doesn't equal the answer. We need to continue. Same thing for the if, right? So if our try parse is false, then we go down into our else statement down here, right? And we want to make sure that these are matched up. We can match them up by selecting the thing here, and it will show you the matching brace. This is the else for this. And then we have an else if here. Else if essentially just gives you another if, right? And then you can do an else on the end. So if you did an else, that would mean that so the else would be, in this instance, because we're checking less than and greater than, your else would mean that the guess is equal to answer. But since we're already checking that up here in the while, we don't need to do that. So again, everything in programming, when it comes to loops, when it comes to logic, evaluates to true or false. And then, your if is true and your else is false. And you can do an else if to kind of, it basically is a little like extension off of your if. So yeah. Again, I hope you guys enjoyed this. The reason that we did else if here, by the way, is because if we just did else, it would also say lower if our guess was equal to answer. So we need to do our else if instead of just an else in that place, because else basically catches everything else. That's why it's an else, right? So if else catches everything that is not true to the if. So if it evaluates to false, it goes into the else. So we needed to make sure that we're checking both. You could also, if you wanted to, you could break this off and just have 2 if statements. That's also okay. The else if wasn't particularly needed, but I wanted to show you guys that it did exist and that it's useful for certain things. You could do 2 if statements here. And be totally fine. All right. So that's it for this one. Thank you guys so much for watching, and I'll see you guys in the next one. Peace.